Hello. This video will go over several problems from the classwork homework of the Introductions to Proof section of the angles unit in geometry. To begin, we're going to start with number 68. To start any proof, you need to set up two columns. So that's what I'm going to do first. The first column is where you put all of your statements. These are anything you want to state is true or the next step of the problem to get to your conclusion. The right side is your reasons. Reasons are exactly that, just the reasons that you have to be able to do the step that you did. In any proof, the very first step is always our given. So we take our given and we write it as our first step. And the reason for it is because it's given. Now, many times after this, you're allowed to use just a G to represent given. So you don't need to write out the whole word given every time. You could just write G, and that's interpreted as it's a given statement. Now, the next thing we do is think about what would we do to solve this equation? What would be our first step? Well, my first step to solve this equation would be to add 6 to both sides, correct? This would cancel out the 6 on the left and isolate the 5x, getting the problem closer and closer to being solved. Well, this step involved adding to both sides of the equal sign, which means that used our adding property of equations. So you can abbreviate it as add prop of equal sign. This represents the addition property of equations. The next step you would take to solving this problem would be to divide both sides by 5 and isolate the x further. That would leave you with x equals 8. And now, look, we've proved it. It's solved. Well, how did we get that? This time we had to use division on both sides of the equal sign, which means I needed to use my division property of equations. And again, you can abbreviate it as div prop of equal sign. And your problem is done. So that is how you would prove that if you were given 5x minus 6 equals 34, you would need to use two properties, the addition property of equations and the division property of equations, to isolate the x and prove that x does equal 8. So we did, in fact, prove it. Let's move on to number 70. Number 69, you would do in a similar way. So we'll move on to 70, which has a little bit more steps to it. And let's see how we do. So I'm going to set up my statements and my reason column. First thing you want to do is write out your givens. So my first given is that equation 2x minus 5, negative 5 times 2x minus 1 plus 3 times x plus 4 equals 24. And that is given. We were told that information. So my first step in this, since I see parentheses and I see a number outside of parentheses, my first step would be to distribute the negative 5 into the first parentheses and the 3 into the second parentheses. By doing this, I'm simplifying the problem. Negative 10x plus 5 plus 3x plus 12 equals 24. To do that, I needed the distributive property. Okay. Now what? The next step would be to combine like terms. So, and You can see as you are saying your steps out loud, they're also giving you your reasons. So we just said the next step would be that we would have to combine like terms, right? The negative 10x and the 3x have to get added to be negative 7x. And your 5 and your 12 get added to be 17. Well, we just said the reason why I was able to do that was because I am allowed to combine like terms. And that becomes your reason. Now the problem becomes similar to the one we just did, number 68. So I'll go through it a little bit faster. Since we need to subtract 17 from both sides here to isolate further, that means I will be using the subtraction property of equations. That would leave me with negative 7x equals 7. And now I'm going to have to divide both sides by negative 7, which means x equals negative 1. And therefore, I'm going to use the division property once again of equations. And did I prove that x does in fact equal negative 1? Yes, we did. Okay. That concludes problem number 70. Okay. Let's remove these drawings from the screen and attempt now a geometric proof. Okay, so let's skip down to 72. And 72 starts us off by actually giving us each statement that we need, and we are going to have to come up with the reason for it. So let's try to do that. Given ABC is a right angle, so we're told that this is a right angle, 90 degrees. You can see how not only did they put it in writing, but they took each of your givens and shown them to you as a drawing. Okay. Many times in geometry, this will be done. They will give you your givens as statements and as a drawing so that you can relate. If you are not given a drawing, I would highly recommend you create a drawing because that's a visual is always better than just words. So then they tell you that this small angle in here is 2x plus 11. And then they tell you that this small angle in here is 5x plus 37. So we need to prove that x is equal to 6. Let's begin. Our first statement rewrites our givens, which means the reason for it is because they are given. Now, we say that ABC is 90 degrees. How do we know that this angle here is 90 degrees? The reason we know it's 90 is because we were told before it's a right angle. So this is the definition of right angles. That's why we were able to conclude that. ABC being 90 equal to 90 degrees is because that's what a right angle equals. So we use the definition of a right angle to determine the measure is 90. Next, we can say that angle ABD is ABD is right here, plus angle DBC will equal angle ABC. And that is from the angle addition postulate. Right? Remember in the last lesson, we learned that you can add two angles together and it'll equal the whole. So we're able to use that postulate to say that the two small angles there add up to be the bigger angle. Now, what the best part about doing that is we are able to substitute. So you're able to substitute out the names of the angles, ABD, DBC, and ABC, to represent what they are actually equal to, the expressions that they are equal to. The reason why we can do this is because of substitution. That one is a simple one. You're able to substitute out the names of the angles for what they're equal to. From here now, we need to start combining like terms, the 5x and the 2x and the 11 and 37. That's how we got 7x and 48, which means our reasoning here was combine like terms. Next, how did they get rid of the 48? They subtracted it from both sides, which means I needed to use the subtraction property of equations. And then finally, how did they get rid of the 7 next to the x? They divided. So I needed to use the division property of equations. And that concludes your first geometric proof on the classwork homework. Let's erase these drawings and try another one. This geometric proof has a line segment. So let's see what we can do with this proof. So our first steps is to look at our givens and rewrite them. And that is what they did in the first line here. They rewrote the given. So my reason for it is because they gave it to me. Now, they said that segment EF plus segment FG is equal to segment EG. Well, the reason why I'm able to say that is because of the segment addition postulate. You're able to add segments together and they will equal the whole. Now, I know what x minus 2 represents EF. I know that 3 times x minus 3 represents FG. And they told me that EG, they gave me that the total length of EG was 25, which means I'm able to substitute x minus 2 in for EF. I'm able to substitute 3 times x minus 3 in for FG, and I'm able to substitute 25 in for EG. So my reasoning for step 3 is substitution. From here, how do I get rid of these parentheses to make 3 times x minus 3 the same as 3x minus 9? I had to distribute. Well, there is your reason, distribution property. You were able to do that because of the distributive property. Now we move on to the next steps. We have to combine our like terms. X plus 3x is 4x, and negative 2 minus 9 is negative 11. So combining like terms. That's why you're able to do that, because they are like terms. And next, how did we get rid of that minus 11 from both sides? We had to add 11 to both sides, which means I had to use the addition property of equations. From there, you can see that we had to separate 4 and x by division. So the division property of equations was used. And now I haven't actually proven anything yet. I've isolated and I've concluded that x is equal to 9, but I haven't actually proved that EF and GH are congruent. Because remember, at the end of the day, the goal for this proof is to show that this segment right here, EF, and this segment here, GH, are congruent, which means they need to be the same size. But now I know what x is equal to. I solved for x, which is going to help me figure out if EF and GH are equal. So let's substitute our x equals 9 into each of these expressions. That's our reason for this. EF is equal to x minus 2, which is 9 minus 2, which equals 7. GH, if I plug in 9 in for the x, I get negative 9 plus 16, which equals 7. I was able to do this because I was able to use substitution x equals 9. We were able to take what we concluded here in step 7 and substitute it in. By doing that, we can say that EF and GH are equal because they have the same measure. EF and GH were equal to each other because they have the same measure. This is actually the transitive property of equations, meaning if one thing is equal to 7 and the other thing is equal to 7, then they both equal each other. So because EF equals 7 and GH equals 7, then that means EF equals GH. Because we're able to say that in step 9, now you can say that EF is congruent to GF because of the definition of congruency. Right? To be congruent means you have the same measure. So because in 9, we showed that EF and GH have the same measure, step 10 allows us to say, well, that means they're congruent now. Okay? And that concludes that problem. So I believe there's one more left in this section. I'm going to do one more geometric proof with you to show you to work through it under the homework section. And we'll work on number 80 in the homework section together. Let's go over number 80. We have been given several pieces of givens. We have been first told angle MNP is equal to 2x plus 5. Angle PNO right here is 5x plus 14. And the entire thing, MNO, is 9x minus 17. So our first step indicates all our givens, which we'll put a big G there because they are givens. Now we can work with our angle addition postulate because we know that this angle plus this angle will equal the whole thing. So we can set that angle MNP, oh, this is supposed to say angle PNO. So angle MNP plus PNO will equal MNO. So once again, our step 2 is going to show that this little angle MNP plus PNO are going to equal your total angle MNO. We are able to say this because of the angle addition postulate. So we'll write angle addition postulate. Remember, a postulate is just a rule. So next, just like we did before, we are able to substitute each angle name for its equivalent expression that they gave it. So that means angle PNO can be replaced by 5x plus 14. Angle MNP can be replaced by 2x plus 5. And angle MNO can be replaced by 9x minus 17. The reason for it, once again, is because of substitution. Now, our next step, how did we get from 2x plus 5 plus 5x plus 14 equals 9x minus 17. Well, 2x plus 5x is 7x. 5 and 14 make 19. What did we do? We combined like terms. We combined like terms. Now, after combining like terms, we now need to start simplifying. So we need to undo steps. So what do we need to do first? We need to move the 7x over and combine it with the 9x on the opposite side. In order to do this, because they are on opposite sides, we need to subtract 7x from both sides. This uses the subtraction property of equations, right, of equals. And then from there, we need to combine the 17 and the 19 by adding 17 to both sides by using the addition property of equations. Now, I do want to point out these two steps could have been interchanged. You could have done them in either order. The reason why is because it wouldn't have mattered if you subtracted 7x first or added 17 first. Either way, you're still combining your x terms from opposite sides of the equation, and then you are combining your constant terms from each side of the equation. So those two steps could have been interchanged. Now, the last step, of course, is the step that isolates x finally. How do we separate 2 from x? We divide both sides by 2, which uses the division property of equations. Now that we know what x is equal to, we can go ahead and plug it into our PNO angle, 5x plus 14. So we can substitute 18 in for x. So our next step is substitution. And we substitute 18. When we solve and plug in 18, we get 5 times 18 plus 14, and we get an angle of 104, which means that the conclusion we can draw is that PNO is obtuse because obtuse, the definition of an obtuse angle is greater than 90 degrees, an angle that's greater than 90 and less than 180. So by the definition of obtuse, PNO is an obtuse angle because 104 is greater than 90 and 104 is less than 180, which follows the definition of an obtuse angle. And that concludes the problem solving section for Introduction to Proofs.